Hello everyone, my name is Kayla Rodriguez and this will be my summer homework assignment for class 13, covering chapters 13. Today I'll be discussing several performance variables, what it means in my own words, discuss additional performance variables that coaches commonly use when evaluating athletes, and finally comparing multiple athletes using these scores from 3 different performance tests. As strength and conditioning professionals, it is really important to understand that athletic performance is much more than simply being strongest or the fastest. Every sport requires a unique combination of physical abilities. For example, football lineman, a marathon runner, a volleyball player, and a gymnast all require different physical qualities to succeed, whether it be strength or endurance, a combination. So because of this, coaches must understand what each performance variable measures and how to choose the correct test for each athlete. The first performance variable discussed in chapter 13 is low speed strength. Low speed strength refers to an athlete's ability to produce a very large amount of force while moving a heavy resistance slowly. So since the resistance is very heavy, the athlete naturally cannot move it very quickly. And this type of strength is often measured with tests such as a 1 rep max, or in exercises like the back squat, the bench press, and the deadlift. These tests measure the greatest amount of weight an athlete can lift one time with really proper technique. Low speed strength is especially important for sports such as football, powerlifting, and wrestling, where producing max force against heavy loads is highly beneficial. Next performance variable is high speed strength, which is more commonly called muscular power. Muscular power is the ability to produce force rapidly. Unlike low speed strength, muscular power depends not only on how much force an athlete can generate, but also on how quickly that force is produced. So in simple terms, power combines strength with speed. Athletes who are powerful can jump higher, can sprint faster, and throw further because they're able to apply force very quickly. Common assessments of muscular power include the vertical jump test, the standing long jump, Olympic lifts, and Olympic lifts. Sports such as basketball, volleyball, track and field, and football very much rely heavily on muscular power because explosive movements occur throughout competition. So track athletes doing long jump, they have to go fast. Another important performance variable is aerobic capacity, is the body's ability to perform high intensity exercise without relying primarily on oxygen to produce energy. Instead, the body depends on stored energy sources like ATP, phosphocreatine, and anaerobic glycolysis. Anaerobic capacity becomes important during activities that last anywhere from several seconds up to about 2 minutes. And examples include repeated sprints, football plays, hockey shifts, and many interval training sessions. Coaches often measure anaerobic capacity using tests like the 300-yard shuttle run because it requires athletes to repeatedly perform high-intensity work while resisting fatigue. On the other note, we have aerobic capacity, which refers to the body's ability to transport and utilize oxygen during prolonged exercise. So aerobic capacity depends on how efficiently the heart, lungs, blood vessels, and muscles all work together to deliver oxygen to the working muscles. So this performance variable becomes increasingly important during longer duration activities such as distance running, cycling, swimming, and soccer matches. Definitely, World Cup was today. Even athletes in sports that require repeated bursts of speed benefit from good aerobic capacity because it improves recovery between high intensity efforts. Common tests used to assess aerobic capacity include the 12-minute run, the 1.5-mile run, the beep test, and laboratory VO2 max testing. The next variable that I will be discussing is muscular endurance. Muscular endurance refers to the ability of a muscle or muscle group to repeatedly contract or sustain a contraction over an extended period without becoming fatigued. Unlike maximal strength, muscular endurance focuses on how long the muscles can continue working rather than how much force they can produce. So common muscular endurance tests include the push-up test, the YMCA bench press test, and the partial curl-up test. This variable is very beneficial and essential for athletes who perform repeated movements during competitions such as rowers, wrestlers, swimmers, and many field sport athletes. Another really important performance variable is agility. Agility is the ability to rapidly change body position or direction while maintaining speed, balance, and control. Agility is much more than simply running fast. It requires an athlete to accelerate, stop, cut, pivot, etc. And in many sports, agility also includes reacting to an opponent or another stimulus. So, for example, a tennis player must quickly react to the direction of the ball while changing direction several times during a single point. Common agility test for this variable is the T-test, the Pro Agility, or the 5-10-5 shuttle, and the hexagon test. Our next performance variable is speed. So speed is the ability to move the body or a body part over a given distance in the shortest amount of time possible. On the contrast of agility, speed generally refers to straight line movement. Sprinting events, football, baseball, soccer, and track all require athletes to perform high levels of speed. So coaches commonly measure speed using the 40-yard dash, the 20-meter sprint, or the 100-meter sprint, depending on the sport. And speed depends on factors such as stride length, stride frequency, muscular power, reaction time, and technique. So the final performance variable discussed in this section is the balance and stability. Although these terms are very much closely related, they are not exactly the same. Balance is the ability to maintain the body's center of gravity over its base of support. Stability refers to the body's ability to resist movement or maintain control when external forces are applied. So balance may either be static, such as standing on one leg without moving, dynamic, such as maintaining control while landing from a jump or changing direction during competition. Good balance and stability improve athletic performance by increasing movement efficiency while also reducing the risk of injury by a lot. Many rehab programs like physical therapy, athletic training programs include balance exercises because of their importance in developing overall athletic performance. So these performance variables provide coaches with valuable information about an athlete's strengths and weaknesses. However, they only represent the foundation of performance assessments. Chapter 3 also discusses several related performance variables that provide even more detail when evaluating athletes, including absolute versus relative strength, different types of muscular contractions, and different forms of endurance and power. So these additional variables definitely help coaches individualize training programs based on each athlete's specific needs rather than using the same program for everyone. So we can go ahead and get started with the next section. The first thing, as I said before, was the first comparison of absolute versus relative muscular strength. So absolute muscular strength refers to the max amount of force an athlete can produce regardless of body weight. So in other words, it simply measures how much weight an athlete can lift. For example, let's say athlete 1 squats 350 pounds and athlete 2 squats 300 pounds. Athlete 8 has greater absolute strength. However, this comparison does not always tell the whole story because athletes often differ in body size. So this is where relative muscular strength becomes very important. So relative muscular strength compares an athlete's strength to their body weight, and it is calculated by dividing the amount of weight lifted by the athlete's body weight. So for example, imagine an athlete weighs 250 pounds and squats 350 pounds. Their relative strength, if I did the math, would be 1.4. Athlete B weighs, let's say 150 pounds but squats 300 pounds. Their relative strength would be 2.0. Even though athlete B lifts less total weight, they are actually stronger relative to their body size compared to athlete A. So relative strength is really important in sports where athletes must move their own body, such as gymnastics, wrestling, climbing, sprinting, and jumping. Our next comparison will be the isometric, isotonic, and isokinetic muscular strength. These terms describe different types of muscular contractions. Isometric strength occurs when the muscles produce force without changing length or moving the joint. Muscles are working but no visible movement occurs. And then an example of this would be holding a plank, holding a wall sit, or pushing against an immovable object, a really heavy object that doesn't move. Isometric exercises are commonly used in PT settings, rehab settings, because they strengthen muscles while limiting joint movement. I'll now describe isotonic strength. So this is a type of contraction most people experience during traditional weight training. During tonic exercise, the muscle changes length while moving a constant external resistance through a range of motion. So exercises such as the back squat, bench press, shoulder press, and bicep curls are all examples of isotonic exercise. Although the weight on the bar remains the same, the force produced by muscles changes throughout the movement because of changes in leverage and joint angles that we went over in chapter 2. So the third type of isokinetic strength. So I'll now describe isokinetic strength. So during isokinetic exercise, the speed of movement remains constant while specialized equipment automatically changes the resistance throughout the movement. This does allow athletes to apply maximum force during the entire range of motion. Isokinetic equipment is expensive though and is mainly used in research labs, rehab clinics, and some sports medicine facilities. Now I will jump into describing absolute versus relative muscular endurance. So absolute muscular endurance measures how many reps an athlete can perform using the same resistance. For example, every athlete might bench press 75 pounds until they can't complete another rep. So since everybody lifts the same weight, larger athletes often perform better. Relative muscular endurance, on the other hand, adjusts the resistance based on each athlete's strength level. So instead of everyone lifting the same weight, each athlete may lift 70% of their individual 1 rep max. This creates a fair comparison because each athlete performs at the same relative intensity. Next is absolute versus relative muscular power. Absolute muscular power is the total amount of power an athlete can generate, usually measured in watts. Larger athletes often produce greater absolute power simply because they have more muscle mass. On the other hand, relative muscular power divides power output by body weight. This does allow coaches to compare athletes of different sizes more fairly. So let's say a lightweight gymnast may produce less total power than a heavyweight football player, but may produce much more power relative to a body weight. Relative power is often more meaningful in sports where athletes must accelerate or jump using their own body mass. Then another important concept discussed in chapter 13 is power endurance, or sometimes called repeated power output. So power endurance refers to the ability to repeatedly perform explosive movements while minimizing the decrease in performance over time. So instead of producing one max jump or sprint, the athlete must repeatedly generate high levels of power. We can bring in a volleyball player that jumps dozens of times during a match. Basketball player repeatedly performs explosive jumps for rebounds and blocks. Soccer player repeatedly accelerates and decelerates throughout a game. And then these athletes depend on power endurance because they must continue producing explosive efforts even after becoming fatigued. Next performance variable is speed endurance. Speed endurance is the ability to maintain high running speeds or repeatedly perform sprints with minimal decreases in performance. This quality is essential in sports such as soccer, football, basketball, tennis, where athletes perform repeated sprints during competition. An athlete may have excellent max speed but poor speed endurance if they become significantly slower after only a few sprints. So coaches often improve speed endurance using repeated sprint training with carefully planned work to rest ratios. And finally, we have agility endurance. This is the ability to repeatedly perform rapid changes of direction while maintaining movement and quality speed. This does combine the concepts of agility and endurance. So a tennis player may begin a match with excellent movement, but after several long rallies, their footwork slows, their reactions become less efficient, and their ability to change direction decreases. An athlete with good agility endurance is able to maintain quick cutting, pivoting, directional changes throughout an entire game despite fatigue. As strength and conditioning professionals, understanding these differences is extremely important because athletes in different sports require different combinations of these performance variables. Powerlifter emphasizes absolute strength. Gymnast depends more on relative strength. Marathon runner requires exceptional aerobic capacity. Basketball player requires muscular power and agility endurance. Soccer player combines aerobic capacity and aerobic capacity, sprint endurance, and agility throughout an entire match. so no, we can say no single performance variable can fully describe an athlete. So instead, coaches evaluate several different qualities and use those results to develop individualized training programs. And this does lead to the next portion of my presentation, where I will demonstrate how a strength and conditioning coach can objectively compare 6 athletes using performance testing and Z-scores. For this Z-score section, I chose 6 female college athletes between the ages of 18 and 21 years. These athletes have all participated in strength and conditioning training for at least 1 year, so I would expect for them to have above average fitness levels, but still show some differences in performance because everyone is different. So to evaluate these athletes, I selected 3 common performance tests discussed in chapter 13. So I chose the 1 rep max back squat, measures low speed muscular strength; vertical jump test that measures lower body muscular power; 40-yard sprint, which measures a straight line speed. So as I said before, using multiple tests instead of only one gives a more complete picture, a full picture of each athlete's physical abilities. Athlete may be strongest in the weight room, but not necessarily the fastest or the most powerful. Likewise, another athlete may jump very high but have average strength. So coaches often combine multiple performance tests to determine who is the best overall athlete. So I have my results for, I hope you can see this. I have my results for the athletic performance from the test. So I have athlete 1, 2, 3, 4, 5, 6, and those would be the results. So athlete 1, I hope you can tell you that. Athlete 1, their back squat was 165, their vertical jump was 20 inches, and then their 40-yard dash was 5.20 seconds, and then moving down you can see the rest. So just looking at these numbers alone, I say as like someone who hasn't seen this before I made this, it would be very difficult to decide which athlete is the best overall. So athlete B has the highest squat, athlete C has the highest vertical jump, athlete D has the fastest sprint time. So since each test uses different units, simply comparing the raw score is it's not really a fair method. So this is where Z-scores become useful. So Z-scores tell us how far a score is above or below the group average. Instead of looking at pounds, inches, or seconds, every score is converted into the same standardized scale. So for tests where higher values are better, such as the back squat and vertical jump, the equation would be Z-score equals the athlete score minus the group mean divided by the standard deviation. So if an athlete scores above the group average, the Z-score will be positive. If they score below the average, the Z-score would be negative. But for the 40-yard sprint, it is just slightly different. So for sprinting, obviously lower times are better. So if we use the normal equation that I just said, the fastest athlete would receive the lowest Z-score, which would be very much misleading. So instead, in chapter 13, the book explains that we reverse the equation. So Z equals mean minus score divided by the standard deviation. This allows the fastest athletes to receive positive Z-scores and the slowest athletes to receive negative Z-scores. So once I calculated everything, right here. Once I calculated everything, these are the scores that I got. So you can see some athletes have a negative, meaning that they were below the average, and some don't have a negative, meaning they were above the average. And I also included the total Z-score, which is really important, as I'll explain right now. But I did want to walk through one of the equations. I have it right. Did want to go over one of the equations. So we have athlete 4 here. So athlete 4 squatted 175 pounds, and the group average was 162 pounds, with a standard deviation of about 16.4 pounds. So if you were to do the math, subtract the average from the athlete 4's squat, and dividing by the standard deviation gives a Z-score of approximately 0.76. And going back up, after finding the calculations for all the 3 Z-scores together, the highest combined score was 2.74. Based on that number, athlete 4 would be considered the best overall athlete. So this athlete performed well in every category, instead of excelling in only one. So going back, athlete B has the highest score, actually athlete 2, sorry, has the highest squat, but their jump performance was below average. Athlete 3 had the highest vertical jump, but lower than average strength. Athlete 4 consistently performed above average in strength, power, and speed, making them the strongest all-around performer. This example does show why coaches rarely make decisions using only one performance test. Athletic performance is multidimensional. Looking at several different qualities provides a much more accurate eval of an athlete's strength and weaknesses. So strength and conditioning coaches can then use the results to design individualized training programs. For example, if an athlete has excellent strength but poor speed, the coach may emphasize sprint mechanics and power development. Another athlete has outstanding speed but below average strength. Coach can focus on resistance training for them. And the ultimate goal for the team is to improve the athlete's overall performance rather than only one physical quality. So in conclusion, chapter 13 demonstrates that athletic performance includes many different components. This includes strength, muscular power, aerobic capacity, anaerobic capacity, muscular endurance, agility, speed, and balance. It also explains the importance of understanding concepts such as relative versus absolute performance and the different types of muscular contractions. And then finally, using standard deviations such as Z-scores allow coaches to compare athletes fairly, even when different performance tests use completely different unit of measurements. Again, this gives coaches an objective method for identifying strengths, weaknesses, and overall athletic ability. Yeah, thank you for watching my presentation. I hope this discussion helped demonstrate my understanding of the major concepts discussed in chapter 13.